Now here's a skill that comes very handy in the GP world. Finding the numbers between two given numbers that are forming a GP. Let's learn about it using a problem. The question is, we need to insert two numbers between 3 and 81 so that the resulting sequence is in GP. What they're saying is, we have 3 and then we have 81 and we need two new numbers that come between 3 and 81 that form a GP. Okay, do you want to give this a shot? Okay. Let's use what we know about GP to solve this problem. If these four terms are in GP, let's assume that these four terms are in GP, what it means is that they have a first term and they have a common ratio. Well, the first term is 3 and the common ratio, let's call it R, that's going to be useful to multiply 3 to get to the next term. So if we multiply 3 by R, we get the next one. We can do the same thing. We can multiply this by R to get the next one, and we can multiply this one with R to get to 81. Now for a minute, forget about the question marks. Let's only look at 3 and 81. What do we do to go from 3 to 81? Well, we multiply 3 by R and then R and then R to get 81, which means we multiply 3 by R cube to get to 81. Let's write that down. 81 is actually 3 times R cube. This equation is very powerful. This should give us the value of R. So 81 times 3 is 27, so R cube is 27. So what's the cube root of 27? Well, that's 3. This gives us R equals to 3 and we can use this to find the question marks. So let's multiply 3 by 3. That gives us the next term. 3 times 3 is 9. And let's multiply 9 by 3 again to get the next term. That's going to be 27. So now we have these four terms. All four of them are in GP. Now we don't need a lot of variables. We don't need a lot of equations. This is the approach that I find most intuitive. Figure out how many jumps are there between the first term and the last term and use that to find the common ratio. Let's try one more. Now insert three numbers between 1 and 256 so that the resulting sequence is in GP. Do you want to pause the video and try it on your own first? Okay, so let's do this together. We have 1 and then we have 256. And between 1 and 256, we have to introduce three numbers. So first, second, third, and then 256. Let's see how many jumps do we have. We have the first one. This is R. Multiply 1 by common ratio will give us the second term. Doing the same thing will give us the third, then fourth, and then fifth. Now, how many times do we have to multiply 1 by R to get to 256? That's 1, 2, 3, 4, 4 times. So this means 256 is equal to 1 times R to the power 4. And we can solve this to get the value of R. R to the power 4 is 256. And this gives us R equals to plus minus 4. Now even powers will give us two results. If you're talking about real values, they'll give us two results, one positive and one negative. Now technically speaking, we need to find the numbers between 1 and 256, which means it's an increasing GP, which means we can take R as positive. But for the sake of it, I'm going to solve both of them. I'm going to put R as 4 and minus 4 and show you both the sequence. So let's see the first one. When R is 4, we get 1 and then 4 and then 4 times 4 is 16. 16 times 4 is 64 and then 64 times 4 is 256. So the three numbers are 4, 16 and 64. And together these 5 do form a GP. But what happens when we put R as minus 4? Well, the first term stays 1. 1 times minus 4 gives us minus 4. And then minus 4 times minus 4 gives us 16. 16 times minus 4 gives us minus 64. And then that times minus 4 gives us 256. Again, I'm not debating whether the second one is correct or not. I'm just showing you that sometimes you can get more than one value of R. You figure out which one makes sense, whether it's one of them or both of them.